When I was 6 years old, I found myself having a snowball fight with my family up at 10,000 feet in the Swiss Alps. Little did I know, those snowballs would change my life. I remember the joy of seeing snow in the middle of summer. When I threw a snowball at my mom, there's a distant rumble. An avalanche had started. I was convinced that I had caused it. So that moment really stuck with me. The power of the ice had imprinted on me. Fast forward 15 years, just by coincidence, I have that same pose and I'm still holding snow. My interest in the cold places of the planet had brought me to Antarctica, working on an icebreaker ship my last year of college. That's when I realized the deeper significance of ice. Glaciers, these vast frozen landscapes, not merely frozen water, but layered timelines of Earth's past, holding millennia-old secrets. They tell us about the rise and fall of temperatures, sea levels, animals, and very recently, human impact, including pollution. Understanding the language of ice is critical to our survival. And now, more than ever, there's a need to foster scientific curiosity and increase ice literacy, which I'll attempt to do in this talk. Glaciers have a disproportionate impact on global climate. Ice reflects sunlight and helps cool the planet. But that natural balance is quickly unraveling. When people learn about the importance of ice in regulating the global climate, they'll see how that impacts their everyday lives and perhaps feel more driven to protect the ice, just like I was. In recent decades, a rapid decline of sea ice has revealed darker, heat-absorbing water below. And as the ocean waters continue to warm, more ice melts. In Greenland, the ice sheet is currently losing around 270 billion tons of ice annually. When melted, that's enough to cover the entire state of Texas with more than a foot of water every year. Disappearing ice starves the apex predator of the North, the polar bear. Now, few are able to travel to the Arctic to see this for themselves. Living so far from the poles, even fewer people may realize what starving polar bears foreshadow in their everyday lives. But melting glaciers can disrupt global weather patterns and destabilize water cycles, sometimes leading to prolonged drought. So no one, not even farmers in Kansas, are left untouched by their demise. Over the past 2 decades, I've had the fortune to journey from the Arctic to the Antarctic, from the peaks of the Himalaya and the Alps, and to tropical glaciers like this one on Mexico's highest volcano, to understand what the ice is telling us. And everywhere, I've seen the same story. Ice is vanishing at an accelerating and perilous pace. In the Himalaya, where I spent my PhD years, there's been a noticeable drop in the ice near Mount Everest in the 87 years between these photos. On the right-hand side of this image, you're seeing a loss of ice of 95 meters. And you always need scale in the Himalaya, so that's just a bit higher than Statue of Liberty. Even near the summit, at almost the height where jetliners fly, there's noticeably less ice. Rising temperatures driven by fossil fuel emissions play a significant role in the story of ice melt. But a visible culprit, black carbon, is also a surprisingly large contributor to climate change. And these are tiny dark particles that come from burning fossil fuels and biomass that can heat the atmosphere. And when these particles land on the snow and ice, they darken the surface, absorb sunlight, and cause faster melting. I've actually seen this happen underfoot while climbing mountains and while working on sea ice up in the Arctic. You can see how dark that snow is there. I've witnessed large calving events where chunks of glaciers break off to form icebergs, like what you're seeing here. While this is a natural process, a warmer ocean accelerates it. On the coastlines of Antarctica, because of this warming ocean, pieces of ice shelves, sometimes the size of small US states, are detaching. Ice shelves are important because they act as a buffer between land-based ice and the ocean. So when parts break off, a sort of plug is released, mobilizing that land-based ice into the ocean. These faraway events can wreak havoc on our everyday lives. So I have 2 containers of water. At the very start of this block, I put ice already in here, which is right at that black mark. This represents sea ice, so this melts and refreezes every year. And when it melts, the water level doesn't change, as you see here. But in the second container, This represents land-based ice. So when this gets melted and mobilized, watch what happens. Hopefully I don't make a mess. Okay, I made a mess. But that's the point. To visualize just how much ice Greenland stores, if all of its ice was to end up in the ocean, it would cause about 23 feet of global sea level rise. If all of Antarctica's ice ended up in the ocean, it would add around 200 more feet. You might recognize this building here. Where we are today at MIT would be completely underwater. While this massive scale of melt may take centuries, sea level rise is already happening. Since 1880, sea levels have risen an average of 8 inches globally. By the year 2050, another foot of sea level rise is predicted, which will displace millions of people living in coastal cities. You can already see this here locally in Nantucket, where communities are being affected by coastal flooding and coastal erosion from the rising seas. As a glaciologist, it's easy to get discouraged. But and then I think about other lessons from the ice. In 1972, deep in the Andes Mountains, a plane carrying a rugby team crashed at 12,000 feet, killing many on impact. The survivors, some with very serious injuries, were left stranded on a glacier. With little food and this shattered fuselage for shelter, they endured 10 days of cold and despair before hearing on a small transistor radio that the search effort had been called off. Desperate, they resorted to eating the bodies of the dead to stay alive. And for more than 2 months, they were forced to face extreme cold, killer avalanches, isolation, and starvation. Eventually, the group chose the strongest survivors to climb out and search for help. 2 of them breached the Andes and brought helicopters to rescue the 14 remaining survivors. Resilience, teamwork, and critical thinking had saved them. That grit and determination is what we need today on a global scale. In 2005, my husband Ricardo, a mountaineer, made an incredible discovery in the Andes. He found a coat and wallet high up on a gully under snow for 33 years before it finally melted out. It belonged to Andes survivor, Eduardo Strauch. And a great friendship was born. For nearly 20 years now, they've returned to the site of the crash with people from all over the world. Some were actually in the crowd here today to share the Andes survivor story. Each year, the melting of these remote glaciers has become more and more evident and dramatic. Since I've joined these expeditions in 2018, I've measured the ice loss myself. At the crash site, the glacier had lost at least 100 feet of ice in only 50 years' time. If the plane crashed today, there wouldn't be enough snow or ice to cushion the impact. The landscape that saved them is disappearing. Unbelievable, right? But here's where hope enters the story, where we can write a better ending. Just as the Andes survivors found a way out of a seemingly impossible situation, we too can find a way out of the climate crisis. For example, in Switzerland, scientists have developed a way to slow glacial melting by covering parts of the ice with geotextiles to reflect sunlight away. You can see that in the photo when comparing the darkened ice in the foreground. It's melted much more dramatically than the part that's protected. The European Union has adopted strict air quality regulations to reduce the black carbon emissions. The US has been passing legislation to reduce these emissions as well, but this progress may soon be in jeopardy. Black carbon emissions continue to rise globally, especially in regions without strict regulation. So obviously, we still have a lot of work to do. We can visibly see it. And these particles can travel long distances, as you can see here, far from their sources, including up to those sensitive polar regions. Black carbon has a powerful warming effect, even greater than carbon dioxide, because it absorbs sunlight so efficiently. Fortunately, black carbon doesn't linger as long in the atmosphere as carbon dioxide. And this means that reducing black carbon emissions can produce rapid cooling benefits. In the climate crisis, reducing black carbon is solvable and scalable. But it requires more funding, more trained glaciologists, more engineers to help us upgrade to the cleaner technologies, and more public participation to help us protect the ice. And here's where you come in. In what's known as participatory science, students, teachers, adventurers, everyday people can collect valuable climate data, which enables scientists to track changes in real time. Snow and ice are natural record keepers and storytellers of the atmosphere. When snow falls, it traps particles from the air, including black carbon. So the snow in your backyard holds clues about pollution levels in your community. Whether in a city or a rural area, snow is part of a global story. Snow sampling can reveal where black carbon accumulates, helping scientists and policymakers to target the sources of those emissions. The benefits of switching to cleaner energy sources and reducing practices like open agricultural burning will not only reduce black carbon, but also carbon dioxide emissions, helping the planet. Tracking black carbon can help in mapping the spread of pollution, pinpoint those pollution hotspots, and assess the need for stricter pollution policy. Ultimately, this effort benefits both human health by improving air quality and the health of the polar ice. For the last decade, I've contributed to this effort, both through collecting snow for my research and by training volunteers on mountain slopes, and one of my samplers is here in the crowd actually too, and on ships in the Arctic and Antarctica. Working off this training already in place, I'm building a bigger scale project called Persistent Pollutants that trains anyone interested in how to collect snow for science. You can see some of the kit here, so that we can get a more comprehensive picture of how the landscape is changing and do something about it. The melting ice tells us that time is running out. But just as the Andes survivors climbed out of an impossible situation, so can we. Resilience, teamwork, and a rational, evidence-based assessment of reality is what saved them and is what we need now. Everyday people participating in community science, advocating for local policy, and supporting cleaner industrial practices can make a difference. Now more than ever, we need to mobilize. We have the tools, the knowledge, and the will to protect our planet for future generations. Let's not wait for someone else to save us. Let's start climbing together. Thank you.